right. All right, this is section 7.1. This is going to be a super short section. It will probably be 6:15 when we're done. Seriously, this is super, super short. But as I said before, rather have two short ones than one super long one. And so we're just going to do 7.1, little more mathy at 7.2. And when we do 7.2, I'm even going to go over some of the homework problems, the ones that are problematic occasionally. So 7.1 is not very mathy at all. We're just going to learn some new things, or we're going to kind of adapt things we already know to new definitions, because we do that stuff. So we're going to look at a uniform probability distribution, and we're going to graph a normal curve. I've talked a little bit about normal curves, and we're going to talk about what the properties of a normal curve are, and then look at what the area means under a normal density function. And so we're laying some groundwork using some things that we're going to be using for the rest of the term. There's only 10 chapters, so we are past the halfway point as far as material goes, because we only have 10 chapters. But we are, after tonight, we are halfway through the class. The last 2 weeks are basically the test and the final project. So we have 4 weeks of, see, we're week 6. So 6, 7, 8, and 9 are more new material. Then 10 will be the last test. And then week 11 is just the final project. So we're halfway, and you guys are all doing great. Seriously, every class struggles with binomial probability distributions. So don't feel like you're unusual and you don't get it, but everybody else in the world does. For some reason, it is something that everybody struggles with. So try not to kick yourself. You'll be fine. All right. So this is a whole lot of words. Basically, this is an example. A uniform probability distribution is when any outcome has the same probability. So we have a friend, and they can be either on time or up to 30 minutes late. And any time in between, any time, so it has an equal probability of being 26 minutes late as you do being 5 minutes late. So all of the intervals of equal amount of time between 0 and 30 are equally likely. So your friend could be 3 to 4 minutes late, or 25 to 26. I already said that. So our random variable can be any value between 0 and 30. It's a uniform probability distribution because every single value is equally likely. So I'm going to graph it in a minute. I'm going to graph it, and you will see what I mean. So with a probability density function, the total area under the graph has to equal 1. So we have 100% probability that he's going to be between 0 and 30 minutes late. So 100% of the time, he's between either 0 and 30 minutes late. So all of it together equals 1. So the area under that graph equals 1. So the height of the graph has to be greater than or equal to 0 for all the values, because if they are equally likely, they're not all going to be 0, because then what are we even doing this for? If they're all 0, why are we even talking about it? So they're going to be greater than or equal to 0 for all of the outcomes. I think we'll go to the graph next. So here's my graph. So equally likely to be any time between 0 and 30, and the area equals 1. So the height of my graph, stop it. Happens every time. The height of my graph is 1 over 30, because 1 over 30 times 30 equals 1. That makes sense. So because any value is equally likely, we end up with this rectangle. Instead of having this pretty curve, we have a rectangle because they're all equally likely. It's kind of like rolling a dice. Any value of the dice is equally likely. So the probability of getting any value on the dice would be 1/6. With this function, every minute is 1/30th probability of happening. It's the same thing. Okay, So we want to know what the probability of our friend being between 10 and 20 minutes late. So we want to know the probability of landing in here. So in order to find that, because this is a nice rectangle, I can just find the area under that and I will get that probability. So I would take this 10 right here, because 10 to 20 is 10, multiply it by 1/30. I'm going to do 10 times 1/30 equals 10/30 or 1/3. So the probability of being 10 to 20 minutes late is 1/3 or 33.3%, because that's 1/3 of my graph. So that would be that probability. I realized I don't have my chat up. There we go. Okay, so it's 10 a.m. There is a probability, 20% probability your friend will arrive between the next how many minutes. So I know that it's going to be 1/30 times something. I'm going to say X because that's what we do. And there's a 20% probability. So that's going to equal 0.20 because there's a 20% probability. So 1/30 times something equals 0.20. So just like instead of 10, I'm putting something else in there that I don't know what it is. In order to get X by itself, this should be your basic algebra, multiply 30 on both sides. Because I don't trust myself, though I probably could do this in my head, it's 6. So X equals 6. So there's a 20% probability that my friend is going to arrive within the next 6 minutes. So all I did was just solve for X, just did a basic solving an equation. Questions? We don't get a lot of these. It's just important that you know they exist. It is possible there could be one problem like this. You just need to know that that they exist. Oh, but here's the other graph. Here's the graph on the we don't know how many minutes. All right. I forgot that was there. Okay. So when we have a relative frequency histogram that is symmetric, we have this nice, pretty bell curve. This is also called a normal curve. If it's bell-shaped, it is considered normal. And I think I've been calling it normal off and on, so it shouldn't be new information, but it's called a normal curve. We're going to be referring to it more as normal than bell-shaped as we move on. Don't worry about inflection points. Inflection points are mostly important if you're doing calculus on these, which you can, and it's a whole lot of fun, but I'm not going to make you do calculus, don't worry. So a continuous random variable is normally distributed. It has a normal probability distribution. If when you graph it, it has this nice pretty shape, this nice pretty bell shape. So it is considered normally distributed. And we're going to be looking at normally distributed things a lot, or we're going to be manipulating things so that they become normally distributed in order to do math with them. Because most of the math that we're going to learn from here on out is going to require that we have this normal distribution. Don't worry about the inflection points. They're not important. All of these are normally distributed. They're just in different places on the number line. Some of them are taller, some of them are shorter, depending on your standard deviation and where your mean is. But they all have that pretty bell curve. They're just different shapes. And they're still bell curves. This pink one right here is still a bell curve. It just has a smaller standard deviation than this one right here. So the bottom one is more spread out, but it's still shaped like a bell. It's still nice and symmetric. These two are basically exactly the same shape. It's just one of them has a mean of 3 and the other one has a mean of 0. But other than that, these are all different normal curves. Okay, there's a big blank There's going to be a whole lot of words on this page. Here are the properties of a normal density curve. Symmetric about the mean. So the mean is your middle point. That is the mu. Your mean is the middle point. I'm not going to require you to memorize these. These are just properties. I'm not going to test you on them or quiz you on them. Because, so when we have a nice, symmetric, beautiful normal density curve, our mean and our median, possibly our mode, all are about equal. So we have a single peak right in the middle, and your highest point is at mu. The area under the curve is 1, just like the uniform density curve that we saw earlier. The area is 1 because all of our stuff is under that curve. All of the probabilities for the entire population is under that curve. So the area under the curve to the right is equal to the area under the left. So each one, you have 50% probability of being on the right of the mean and 50% probability of being on the left. Give you a minute for those of you writing stuff down.
The PowerPoint paper says 3, it has an inflection points of mean minus standard deviation and mean minus standard deviation. And then the 4 says,
it was right here. You're talking about that?
No, it's on the slideshow. We have
Yeah, I think that I took those out because I didn't like them.
okay. Okay.
Yeah, because I didn't want you worrying about inflection points. So I believe I took those out.
Right. Okay.
oh
Yeah.
yeah, it was still in the PowerPoint. I downloaded it too, so I'll make it.
Yes, I'm working on it. I'm working on updating things. Sorry about that.
Oh, that's okay.
Yeah, I'm not concerned about inflection points. Inflection points are the place where concavity changes, and unless you're in calculus, that really has no meaning to you. And so I kind of just dropped it. And so yeah, I figured one less term for you to memorize. So as x gets bigger and bigger and bigger, the graph approaches but never reaches the horizontal axis. As x gets smaller and smaller and smaller, the graph approaches but never reaches the horizontal axis. So when we have our curve, so if this is my axis, it's going to get super close, but it's never going to touch it. It just gets super, super close. So if you've, I don't remember which math it is. I don't know if it's in 65 or 95, but if you remember asymptotes, so the x-axis is an asymptote. And if you didn't get that far in math, it's not a big deal. It's just, I really like the word asymptote. It's one of those words that's fun to say and fun to write because I don't know. Because I'm a child and I like math. There you go. So the empirical rule applies. So all we're doing is just transferring the name of the graph where we're just calling it a symmetric bell curve. It is the exact same thing. The empirical rule applies here. So about 68% of your area is 1 standard deviation away from the mean, approximately 95% is within 2, and approximately 99.7 is between 3. So it's the same thing. We're just saying the empirical rule does apply here. As I said before, it doesn't go away. Empirical rule never goes away. But it is approximate. So as we get to on Thursday, when we learn our new math tools, you will see that 95% is not exactly 2 standard deviations. I think it's 1.95 really, rather than 2, but we rounded for the empirical rule because it says approximately. So they're not exactly, but they're really close. All right. So we have our nice pretty graph. You've seen this 1,000 times, but it is still pretty. And except we don't have this right here. I don't know why this one doesn't have these. I'm not really sure, but I really do. I mean, this is one of my favorite one of these drawings. It's kind of pretty with the different shading, but it is the same. It's the same thing. It's just now we're calling it a normal distribution. We're just changing the name. Right. We might even get done before 6:15. You guys need to like ask more questions. We could always go over anything you're stuck on the homework because we'll have time. All right. So we have some data on the next slide. It represents the height in inches of a random sample of 52-year-old males. We're going to draw a histogram of the data using lower class limit equal to 31.5 of our first class. We're going to have a class width of 1. And we're going to take a look at whether the height of 2-year-old males is normally distributed. So I'm not making you do anything with the data. This is just the raw data right here. A whole lot of it. Here is my beautiful histogram. As you can see, it is, I could draw the curve over there. It looks like there might be a slight skew, but it's so very slight. There's barely a skew. So, I would definitely call this mostly normal or approximately normal. Looks like this right here is the most common height of a 2-year-old male, between 35.5 and 36.5 inches. Sounds about right. I think most of my grandkids are short. All but one. I have one grandson that's really tall. It's going to be 2 and he's very tall. Anyway, I will. So we have here's a normal density curve that I have drawn over the histogram. So we're going to talk about what the area of a rectangle between the 34.5 and 35.5, what that would mean. So take a look right here. So I could take this curve, right? If I took this piece off and put a little bit of it under there, it would mostly fit under there. Now, if I start making these rectangles smaller and smaller and smaller and smaller, it's going to fit prettier and prettier and prettier over there. So this area right here under the curve, if I found the area of that rectangle, it would give me approximately the probability of randomly choosing a child between 34.5 and 35.5 inches, or it would tell me the proportion of 2-year-old males that are in between that. So finding the area under the curve helps us also to find that probability. And there are some really fun calculus ways to do that. But as I said, I won't make you do calculus. So Thursday, I'm going to give you a really fun calculator program, and it will do all of that math for you, which is great. I love that the calculator will do it all for you. All right. So the area under the normal curve. So this is pretty much exactly what we've been talking, what I just said. So if I take the area under the curve, so if I take the area between two values, like as I said, like back here, between 34.5 and 35.5, there are two different things that it can tell me depending on the question that's being asked. The first one is, it's the proportion of the population with a certain characteristic. So it would tell me the proportion of 2-year-old males that are between 34.5 and 35.5 inches tall. That's one of the things it could tell me. The other thing it could tell me, it's the probability that a randomly selected individual will have that certain characteristic. These are basically the same thing. It just depends on what question you are being asked. So if you are asked what proportion of the population of 2-year-old males is between 34.5 and 35.5 inches, you're going to answer using this. Or what is the probability that if I randomly chose a 2-year-old child, it's the probability he'd be between those two values. So it is the same math. It is the same thing. It just depends on the question being asked. Your questions? Does that make sense? All right, I'm going to move on. I only have 2 slides left. We definitely should probably do some other math together. All right. So weights of giraffes are approximately normally distributed with a mean of 2,200 pounds, as I just went to the wrong screen, and a standard deviation of 200 pounds. We're going to draw a normal curve and we're going to label stuff. we're going to shade the area of the curve to the left of 2,100 pounds. And then we're going to interpret this number right here, which is the area under that curve that I've shaded. So here we go. Here's our normal curve. Pretend you can't see that shading, because now you can see that shading. So this area right here under the curve is that 303085. So this area 0.3085. So it's about 30.8% or almost 31% of the normal curve is shaded. That is that area right there. So the two different interpretations that we have is the proportion of giraffes whose weight is less than 21 pounds, 2,100 pounds, is 0.3085. We also have the interpretation, the probability that a randomly selected giraffe weighs less than 2,100 pounds is about 0.3085. Questions? See, I told you there was really no math today. Because all the math is Thursday. All right, so I know we've only been talking for half an hour. That's all my slides. So we have a couple of different options. We can just end the class. We can be done and you guys can go enjoy your 70-degree weather, 67 according to my watch, 70-degree weather. We can go through a few problems of binomial, certain things that you are confused about. Or a third option, which is probably not the one you want, but could be, I could grab Thursday's lesson and we could go through all of that too and finish late and not have a class on Thursday.
Oh, that's a
If
tough
I did
one.
Thursday, what was that?
That's a tough one.
I'm happy to do any of them, but any of those three suggestions. But let me pause at least here. All right, we're now in 7.2. We've decided to do 7.2 today, and then we are not going to have class on Thursday. So this is going to be fun. Right, so we're going to find and interpret the area under a normal curve, and then we're going to find the value of a normal random variable. So basically, we're going to take the area under the curve. We're going to use that area to find the value that goes with it. And you may recall way back in your way back machine to an earlier chapter. We're going to look a little bit at z-scores today as well. So if you have I almost said rememory. If you have any memory of z-scores, then pull those out of the files where you filed those away. All right. So this right here, we know we've done this before. This is how you calculate a z-score. We used z-scores to determine how many standard deviations things were away from the mean. The z-score is also really useful to standardize things. We talked about it before when we were comparing two things that were not alike. Like we compared two basketball players' heights. They had different means and standard deviations. So when we gave them both z-scores, it was easier to compare them. We do the same thing with a normal distribution. If all of my values are converted to z-scores, it is really easy to tell if something is an outlier, because if you have a z-score that's bigger than 2, it's an outlier. So when you have made your normal distribution into a standard normal distribution, right here, when you have converted it to a standard normal distribution, we now have a mean of 0 and a standard deviation of 1. So when we are using z-scores with a standard normal distribution, our mean is 0 and our standard deviation is 1. It makes life really easy when we standardize it. Let me give you a moment. So a regular normal distribution just uses data values. Standard normal distribution uses z-scores. The reason I'm keep saying this is because a little birdie told me that there's a question regarding that on the quiz for this week. So FYI. this page right here, it's flag it or something because there's a definition question on the quiz about this. But you didn't hear that from me. All right, give you a moment. We will move on. All right. So we've done this before. So I'm just calculating a z-score. So I have an IQ, a mean is 100 and the standard deviation is 15. I want to know the z-score associated with an IQ of 120. So you take the value minus the mean, and then you divide by the standard deviation. So the z-score for an IQ of 120 is 1.33. We all know that that's not an outlier because it's not bigger than 2. So you just take the value minus the mean, divide it by the standard deviation. If you're putting the whole thing in your calculator at the same time, I cannot emphasize this enough, put parentheses around your numerator. If you're putting it in the calculator, put parentheses around your numerator. There were a couple calculation errors on the last test because I'm thinking the reason was because the parentheses were not around the numerator. They ended up with something like an 87 z-score or something like that. All right, moving on. So in your materials for this week, you should be able to see something called a Z, and it says Z and T tables. The Z table, it is kind of interesting. It's not necessary to use because we're going to be using a calculator, but it will tell you the area under a curve to the left of a certain z-score. So we have a z-score of 1.33. So the first digit, the whole number, plus the number in the tenths place, you look that over here. And then you will move over to the column that has the hundredths place. So we're looking at 1.33. So I have 1.3 is right here. Then you go over to where 0.03 is. And this right here is your area under the curve to the left of that z-score. So if I drew my normal curve here, sorry. If I keep my normal curve there and I draw, there's my line at 1.33. The area over here to the left of that is that 0.9082. This is how we use a z-score. I'm going to show you where to find the z-table in the, the materials. I wasn't expecting to be here, so I'm going to have to, let's just do this. I didn't have this up yet, but it should just take a moment if my internet behaves. So in Blackboard, if we log in, if it will let me log in. Please wait while the module loads. Okay. It's thinking about it. Okay. So if we scroll down and look in this week's materials. Okay. Maybe it's processing my request. Right at the top, it says tables Z and T. We open this. Maybe. Okay. The first page is the Z table. Ignore the second page for now. We won't need the T table for a couple weeks. Maybe. Come on. Open, open, open. It's thinking about it. Come on. It should open. It's resolving the proxy, whatever that means. Okay, here it's coming. I see it. All right, maybe. I'm going to give it a minute. I'll come back to it. We'll go back to it in a minute because it's not fully loaded yet, and I don't know that I want to wait. Come on. Oh, there it is. Wait, no, stop. Okay. See, and I went and refreshed it. It should be fast now. Hi, ay. Okay. So if you look, here's the Z table. This is the one you have. And so you look for the whole number and the tenths place in this column. It starts at negative 3.4. So I would look for 1.3, which is way down here. So 1.3 is way down here. And the 0.03, which is my hundredths place, is right there. So just scroll down. So right here, I have the 0.9082. Remember, this is the area to the left. If you needed the area to the right, you would have to do 1 minus, but this is the area to the left right there. Don't worry, I'm going to give you a calculator function in a minute, and it will do all of this for you. I just want you to know that this Z table thing exists, and it will become more useful later on. Okay. So, hey, look, I just drew this picture. So if I was, as I said, if I was looking for this area right here, I would do 1 minus. But this area here to the left of that 1.33 z-score is 0.9082. All right. So in your calculator, this is our calculator function. So pull out your fancy schmancy calculator. You're going to be using a function called normal CDF. We will never use normal PDF. We are only using normal CDF. So don't worry, you don't have to be like, oh, which one do I use? But I'm going to show you how to do this, and we're going to do it with the 1.33 z-score. So here's my calculator. You probably saw the normal CDF function when you were scrolling down to get to the binom. So we'll do second vars, and normal CDF is your second option. So I'm going to do this in a second. So I'm looking for less than 1.33 for my z-score. All right. So their lower value, basically we call it negative infinity, but it's 1e99. Remember I told you about scientific notation? So this is negative 1e99 is basically negative 1 times 10 to the 99th power. So it's a really small number. So put in negative 1. So the negative is right here next to the decimal. And then 1, I'll show you where to get the E. The E is right here above the comma. So if you hit second comma, you will get your E. And then 99. This is negative infinity. Once again, it's negative 1. The negative is this right here next to the enter key. It is not the minus. If you use the minus, it's going to give you an error. So it's this negative right next to the enter key. So negative 1, the E is right, it's the blue right above the comma. So you do second comma and then 99. My upper value is 1.33. That is my z-score associated with the 120 IQ. When you are using z-scores, your mean is always 0. Your standard deviation is always 1.
So if it's anything less than the probability, will it always be the negative 1e99?
Yes. And if it was greater than, it would be you'd have the number here, and then you'd have positive 1e99.
Sorry, say that one more time. You'd have,
If I was doing greater than, I would put my 1.33 in the lower bound.
oh,
then I would
gotcha.
put positive 1e99 in my upper bound.
Gotcha.
It's
Thank
basically
you.
infinity. So remember though, whenever you're using z-scores, our mean is 0 and our standard deviation is 1. I'm going to paste that. And I got basically the same, I have the same value that they got. I'm going to do the greater than now just so you guys can see it. So I'm going to do second vars, normal CDF. My lower value is going to be 1.33. My upper value 1, then second comma, then 99. Leave my 0 and my 1, paste it. And then I have the upper greater than. Don't worry, we'll get plenty of practice on this. One thing nice about the normal CDF though, is you don't have to use z-scores. So let's actually use my actual values. I'm going to do second vars, normal CDF, and I'm going to do greater than 120 for my IQ. So my upper is still 1E99. My mean was 100. My standard deviation is 15. So if you are not using z-scores, you put the actual mean and standard deviation in there, and I should get the same thing or really close. It's close enough that you're going to be just fine. All right, questions on that? We're going to have more practice as we go. All right.
So you said, when you don't put the 0 and the 1, when?
When you're using actual values instead of z-scores.
Values and not c-scores. Sorry, I was trying to write that down.
No, it's fine.
Okay, thank you.
All right. So this is really good example. So you use your lower bound, upper bound. I'm just going to write here. So normal CDF, I'm going to write it out in words here. Normal CDF, lower bound, upper bound, mu, sigma. So mean and standard deviation. This is how your normal CDF will look. Because some people don't have those fun spots to put things in. So if you're just typing it into your calculator, this is what it'll look like. We're going to get some more practice, so this should help. All right. I'm going to move on. And anyone need a moment? Okay. We already did that. Okay. All right. So this actually, I just remembered that there's an error on the pre-recorded video of this. I need to fix that. So using z-scores, so if I'm doing the probability that z is greater than, if it puts a z right here, we're using z-scores. So for example, if I'm looking for the probability z is greater than 0, since 0 is my mean, it's going to be 50%. We just did this one. Probability z is greater than 1.3. We just did that. It was normal CDF. And we wanted greater than, so it would be 1.3, 1E99. We did 0 and 1, and we got approximately whatever that was on my calculator, which was 0.0917. 917. This is what we just did. Now, supposedly on calculators where you just type it in, you don't have to put the 0 and the 1, but most calculators, you type it in those little spots. So this kind of doesn't matter. So if you have a calculator where you type it in, if you don't put in this right here, it automatically assumes it's a z-score. But I think most of us actually have the spots where it asks for those things. So we're going to kind of ignore that. Don't worry, we have more examples.
So is E99 the same thing as 1E99?
Yes, it is.
So it doesn't matter if you put the 1 there or not?
I've never tried it with just E99. I've only ever tried it with one E99. So I'm not going to commit.
So play it safe and put the 1.
Yes. It's
Okay.
probably fine, but I'm not going to commit. Okay. And we just saw with our calculator, we just saw with our Z table. This is the Z table we have. Well, part of it. We saw that that's the Z table, and we would do 1 minus that. All right. So let's find the area
I
under.
just tried it.
What was that?
I just tried it. I just tried that with just the E99 and it gave me a negative 0.0917.
Oh, okay. So it did something wonky. So let's not do that then. Thank you. Thank you, Lonnie. Okay. So let's find the area under the standard normal curve between z-scores of negative 1.02 and 2.94. There is a way that you can do this with your Z table, but let's just not even go there. It's a lot of extra math. So instead, we're going to use our normal CDF. We'll do normal CDF. Your lower bound is 1.02. Your upper bound is 2.94. Your mean would be 0 and your standard deviation is 1. So because we're looking between those two values, this is so much better than using the z-score because we would have to be subtracting things off, and we don't want to go there. You know, we have a calculator for a reason. It's your friend. Right. So I'm going to go to my calculator. Let's do this normal CDF. Maybe. Come on. For some reason, my calculator is now being rude to me. It is saying, why am I working? Okay. Second, come on. It's not even working. Okay. I don't know what's going on. I'm going to go back to the other screen. I'm going to use my regular calculator. So go
Mine
to
says 0.8445 rounding to the fourth decimal.
I don't know why my calculator quit working. Okay, I got approximately 0.8445. Is that what we got?
Yeah.
Okay.
Yep.
Questions? So far, so good.
Well, there's actually a question on my homework that I guess I'm kind of stuck on, and we can talk about it afterwards too. I don't want to interrupt
I have a
this.
couple examples from the homework that are at
Okay.
the very end, and hopefully that might answer your question.
Okay, perfect. Thanks.
Yeah. All right. So if you were looking, I mean, you can use your Z tables or use your technology. I recommend using your technology. I like that you have a knowledge of the Z table because it's going to become useful later, but I highly recommend just use your technology because just use your technology. Okay.
Easier.
Huh?
It's easier.
Okay. So sorry. Okay, so if we were finding in between, this shows you how to use it with your Z table. But as I said just a second ago, use your technology. Stop it. Go away. That weird thing popping up. I don't understand. Okay, let's go to the next thing. I already showed you this. So the 1E99 and the and the negative 1E99, if you have the PowerPoint, it might look a little bit different from this. I updated it just recently a little bit. And so this is a better representation. I already have a note to myself to update the PowerPoints in the class, quit using old ones. So there's a note. It's this summer, I'm going to be doing a lot of that. It's just that teaching like term after term after term, it didn't leave me a whole lot of time to update things. So I'm sorry. Okay, going to move on. Okay. Sometimes we have a percent or we have an area, but you want to find the value that goes with it. So I might be looking for the z-score that goes with it, or I might be looking for the actual value that's with it. And so it's important when that's the case that we use a different function, or you can still use your Z table, but let me tell you, it is not fun using your Z table for that. So I might want to know the height of a 2-year-old male that is in the 20th percentile, or I might want to know which scores on the standardized exam separate the middle 90% from the bottom and the top 5%. So sometimes you want to know that. Sometimes you want to know, okay, so which SAT score is going to put me in that 90th percentile. So sometimes those things are important. You want to know what do I have to do to get that? What score do I have to get? So we have a function for that as well. So you can draw the normal curve if you'd like. Then you can look into the body of the Z table and look for what corresponds to that shaded area. I do not recommend this method. And then you can use, I don't recommend this at all. You can use this formula, which is basically just solving for X on your X minus mu, this is a mu over standard deviation. Basically what they did was they just solved for X and got this. As I said, I don't recommend this. Instead, we're just going to use a calculator function, and hopefully my calculator will be nice to me. The calculator function we are going to use is called inverse norm. If I can get this to let me write on it. Inverse norm. Norm, this should have an R in there. Inverse norm is the calculator function that you're going to need, and it is area, then mean, and standard deviation. If you're looking for a z-score, as I said before, the mean is 0 and the standard deviation is 1. If you are looking for actual values, use those values instead of your 0 and 1. Don't worry, we're going to do some examples. Hopefully my calculator will be kind to me. If not, we will make it. We will make it through. Okay. Let's get there. Oh, look at that. It was there and I didn't even know it. It was right there. Yes, inverse norm. Inverse norm is located on your second vars. It is right under normal CDF. So I don't care about that. Okay. So the combined verbal and quantitative reasoning score on the GRE is normally distributed. It has a mean of 1049 and a standard deviation of 189. We want to know what the score of a student is whose percentile is in the 85th percentile. So fingers crossed that my calculator works. Where is it? It even left me. Yeah, I don't know why it is being mean to me today. I just worry that if I click on it again, it's going to say that there's already an instance running. Okay, I've got a blue screen. Anybody remember the blue screen of death? I don't think we see those anymore. You guys remember that?
Yes.
I just triggered a core memory, didn't I?
Oh my goodness. You're making me
know
feel older and with the open. I thought I was the only one who said that too. That's funny.
Isn't that like Mervin's or
Yes, Mervin.
Penny's or something?
Yeah, it was a Mervin's Black Friday
Yes. They
commercial.
would stand outside going open.
Yep.
See, I knew this was going to happen. Okay, so my calculator is being so rude to me today. Sheesh. Okay, I said to make this instance inactive. Let's see if it's going to be nice to me now. One more time with feeling. Every once in a while, I'll do one of these old references, and one of my high school students will get it. And I'm like, you're my new best friend, seriously. Because at my age, very few young people get what my reference is, because I have a lot of really weird ones. Yeah, I don't know why this is being rude to me today. So rude. Okay. So you guys are just going to have to bear with me. In your calculator, fancy schmancy calculator, go to second vars and then go down to INV norm. Okay. Your area is going to be 0.85 because we're at 85th percentile. And since we want a specific GRE score, you're going to put 1049, 1049 in for your mean and 189 in for your standard deviation. Now, some of you may have these options left, center, right. Some of you will not have that, but some of you will. You want left because we are looking for the area where we have the area of the curve to the left of 85, right? We have that area to the left. So you're going to use left. If you don't have that, it's automatically going to give you left and you're good. So then
Can you repeat what you put in? Sorry.
Okay. For area, I put in 85 because we're looking at the 80 or 0.85. because I'm looking for the 85th percentile. So essentially, I have a normal curve like this, and I have the 85th percentile is right here, 85th, 85%. So this right here is 85% of my curve. So I'm looking for what is the value that hits that 85%. Does that make sense?
Yeah.
Okay, so you put 0.85, then your mean is 1049, and your standard deviation is 189. If you have the tail option, we want left because we have a 85% to the left of our value is shaded. Then you'll paste and hit enter, and you probably got 1244.89-ish. 1244.
I got the answer too, but it didn't say like it didn't give me the option to say left, like you just
It's
said.
okay. It automatically defaults to left. If you don't have that option, it automatically defaults to left.
Oh, okay.
And because that is the most commonly used one, is left. I'm going to go back to my calculator real quick and see if I can make it work, because this is really annoying. I don't know why it does that, because I'm on the same window. I don't know why it would just decide that I already have. Oh, look. Yay. Okay. Let's see if it lets me sign in. It's so rude. Maybe. Okay. Okay, I'm here. I got you.
Kidding.
It's thinking about it. I don't know what the deal is with the calculator today. I think my computer is just tired, but it hasn't been working at all today. It has been closed up in my backpack all day. It's about time it gets a job. Okay, there we go. Okay, I'm gonna see if I can make it work. So just for those of you, yeah, it's not working. Okay, well, we're gonna do fine without it. Y'all are awesome. We'll be fine without it. Let's do another example. Actually, let me show you this first. So if you were using your Z table, which I really don't recommend. So this is my Z table. And the way you would do this, so the Z table, remember, shows you it gives you the area to the left of your Z score. So I would look at my Z table and I would look for the value that's really close to 85 or 0.85. So notice right here, I have 0.8485 and I have 0.8508. This one is a little bit closer, so that's the one I would choose. So
I like hearing you say that we're not going to have to do this, right?
No, I just want to
Because-
show you that it's a thing.
Okay.
So what I can do is I can plug the Z score that corresponds, which is 1.04. 1.04 equals X minus my mu, which is 1049, divided by the standard deviation, which is 189. And then you would just solve for X. Don't do this. Use inverse norm. Just thought I would throw that out there, that this is how you would do it. You would multiply both sides by 189. 189 times 1.04, and then I would add 1049 to it. So I got 1245.56, which is really close to this, but we had to round for the Z score, or because where it was in the body, but it's really close. But don't do this. I'm just showing you it's a thing and you can do it. I do have students though every term that just prefer to math it out and are like scared of the calculators. But I recommend getting over that fear and leave the Z table be. All right, moving on. Okay, yes, I got that. All right. So I would like you to try this. The weight of giraffes are approximately normally distributed with a mean of 2,200 pounds and a standard deviation of 200 pounds. What would be the weight of the giraffe in the 75th percentile? See if you could try this on your own. We are in I will work behind you. How'd we do? Do good? Okay. If you have left, just leave it on left, because and if you don't have left, then don't. It defaults to left. I've never used right, just FYI. I do occasionally use center, but I can show you how to do the math without using center. So if you don't have those options, it's okay. Questions before we move on? All right.
So we didn't have to put anything in the lower.
No, all you have, the only options you have is area, mu, and standard deviation. So these are the only options you have. There's no upper or lower for inverse norm.
You're right. Okay. I went to the normal.
Oh, okay.
PDF.
Yeah, that'll mess you up.
Yeah.
Are you good?
Got it. Yes. Thank you.
Okay, so this is the place where if you don't have the left, center, right options, I'm hoping that I don't mess you up too much. Drawing a picture is going to help here. So we know that the length of a certain steel rod is normally distributed with a mean of 100 centimeters and a standard deviation of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods. We want to know the length of rods that make up the middle 90%. So we're looking for the middle 90%. So I'm going to draw a picture. Bet you guys didn't know I'm a professional artist, right? I mean, I'm getting paid to draw this, so that makes me a professional artist.
Is that in your 500?
Huh?
Is that in your 500 mistakes?
Yep. Okay. So this is the middle 90% right here. That means there's 5% up here and 5% down here, right? Because it's the middle 90%. So this right here is the 95% mark, right? So
Yeah,
if
it should be.
what was that?
Should be. Yes.
Yes.
Sorry.
So if you
I
don't
know.
have the left, middle, right option on your calculator, their left, center, right, you need to put 0.95. So it would look like this. Inverse norm, 0.95, and then 100.45. And this will give you your upper value. This right here is 0. This would be the 5% mark, right? Because we have the middle 90%. So you would also need to do a second one with inverse norm, 0.05, 100, 0.45. And those will give you
confused.
those two values.
So, you said if we don't have, what was it?
This is only if you don't have center. If you
How
do,
do you know if we don't?
when you do inverse norm, let me see if I can get my calculator to work again. Okay. Yeah, my calculator's not working. So when you do inverse norm, just a second here. I'm going to do my inverse norm. I'm going to draw it because my calculator is being rude. So what I have on mine says area. Then I have mu. I have standard deviation. Then I have tail, left,
Oh,
center, right. And then paste. Some people do not have this.
Yeah, I don't have that.
Okay. If you don't have that, then you need to do both of these calculations. And
Okay.
thankfully, inverse norm, and I'm sorry, I went off the edge of the screen. This is 0.45 down here. Sorry, I went off the side of the screen. So if you don't have the center, the left, center, right, you'll just have to do both of these calculations. So I'm
When
gonna-
it asks us to determine the length of the rods that make up the middle. So when it asks us to find the middle, then we do both of those calculations.
Exactly.
Okay.
Does it default to center? I
It-
mean,
no, it's gonna default to left.
oh, it defaults to left. Oh,
It
okay. so you
defaults
have
to left. So basically what
Okay.
you're finding, what you're gonna find, you have is this 95% area first, and it'll give you this value. And then the second one gives you this uses that area right there. So the middle 95%, you need to remember it's the middle. So you have 5% above, you have 5% below. So here, for this top value here, I got 100.74. For the bottom value, I got 99.26 approximately.
And then you're adding those together?
Nope, those are your two values. It'll give you
Okay.
like parentheses, and you put those values in your parentheses.
Okay.
Or brackets, or however it decides it wants it. So it'll want two values. So you just give it those two values. If you have that center option, does anybody here have that center option? So if anybody had the center option, you could do 0.9 and then just do center. But basically that center option, it was a recent, somewhat recent, couple years ago, update in the calculators. And so only with the most updated operating system do people have those. But y'all didn't know you have to update the operating system in the calculators. But it's a process. So don't worry about it. If you can do the middle something percent, you're good. I only have one more slide, and it's just 7 now. So we're doing awesome. Any questions on this before we go move on?
Yes, so after you got the 100.74 and then the 99.26, did you say you added them together?
No. So it
I missed
says
something.
determine the
Okay.
lengths of the rod that makes up the middle. The way you'd answer it on my open math, I believe, would be like this. I think that they want it in an interval like that. Or it will say the smallest
Oh.
rod is, or the biggest rod is, because this is just my endpoints.
Gotcha. Yeah. Okay, that makes sense then.
Okay, good. Any other questions? All right, let's take a look. Okay. All right, so the same thing with z-scores. The cool thing about z-scores, though, if I do it with z-score and I find a positive z-score, the one on the other side of the middle is just the negative value. And this is just us doing all that math again. Just gave us the answer. So we're going to go to the question I think that that somebody was going to ask me. And if I'm wrong, I'm wrong. But I'm going to go back to my open math real quick, because that was the end of that. And now that my calculator is being ridiculous, I'm going to go to my open math and we're going to talk about maybe. Come on. Is it even going to let me log in? Let's see here. See, worst comes to worst, I'll go on my other computer and you're talking about the 7.1 and the 7.2 homework. Did you already look at that? Is that what you're talking about?
Yeah.
Yeah, okay.
Um,
I'm gonna go right here. Hold on a second here. I'm gonna scroll down. So I think I have an idea of what you're talking about. Come on, you can do it. Okay. So these ones are pretty easy. These are just finding z-scores. You'll use 0 and 1 for your mean and standard deviation on all these z-score ones. These will be super fast. And then these ones are all inverse norm ones. Okay. My guess is these ones right here. Is this what you're talking about?
No, actually. I mean, I probably will have questions on those as well. The one I'm stuck on is it says about blank percent of the area under the curve of the standard normal distribution is between negative 1.39 and positive 1.39.
Let's see here. Right. Oh, this one right here.
Let me go back to your screen. Yeah. And so what I got was 80. Well, I rounded it up and it was 84%, I think.
Okay, so it should just be normal CDF, and you should be like this one be negative 0.39 and then positive 0.39 and then 0 and 1. So it should be, this would be 30.3. Yeah.
Okay.
So you should just
What
use
did I do
normal
there?
CDF with this is your lower value and this is your upper value. Did you try
Okay.
that?
Let me do that real quick because I don't.
These
Yeah,
are
I feel like.
your values will be different than these, but
Mhm.
the same concept.
Yeah.
I'll put the answer right there.
Okay. Let me do this real quick.
Can we click on the key to see what it was supposed to be if we got it wrong?
You should be able to.
Oh, I didn't know that.
I didn't know that either.
Yeah, once you get it wrong, if you can't answer it again. So
Right,
once
after
you
you
can't answer
decide.
that specific question again, you can click on the key and see what the correct answer should have been.
That would be nice to figure it out.
Yeah.
So I did that one again and I got 0.835 for blah, blah, blah.
Did you use 0 and 1 as your mean and standard deviation?
Yeah.
And
So I'm not
negative 0.39 for your lower normal CDF, right?
Yep.
Okay, negative 0.39 is your lower. And positive 0.39 for your upper.
Well, it's negative 1.39.
Okay, this is
And
different.
then positive
Okay.
1.39 for upper.
Yeah, you have different values than I do.
Yes.
So let me look with the 1.9.
Are you rounding to the 2 decimals instead of 4?
Comma 0, comma 1. Okay, so I got 0.835. Is that what you got?
Yes.
Yep, that's the correct answer. Is it possible you rounded wrong or didn't use enough decimals?
So what would be the percentage?
So it would be 83.55 should have been what you put in there.
Oh, okay. I rounded to 84. That's why.
Yeah, it should be 83.55. Yes.
83.55.
Because
Okay.
once you convert it to a percent, then 2 decimal places.
Okay. Gotcha. Thank
All
you.
right.
That
You
makes
guys want me
sense.
to look at those other things here real quick? These ugly ones?
Yeah.
Yeah,
These are
please.
just Z-scores. It's just showing you ugly, and these are just Z-scores. So it's really not that bad. In fact, it gives you the Z-scores right here. It's just showing you this funky picture because it's showing you, it's kind of like the drawing I did where I shaded it, but obviously mine's better. So that's all that is. And this is the same thing. So this is a shaded area that's 99%. So you would just do inverse norm, 99%. This one right here is the upper. So you would do 0.85, but then you would do, actually you would do no. So this is a negative. So the shaded area is 0.85, which means this right here is 0.15. That makes sense. So you would do 0.15, because remember yours defaults to left side. Does that make sense? So you need to think about the fact that your inverse norm defaults to left. So if it defaults to left, you would have to use 0.15 to get what this Z-score is. Because you can see the Z-score is a negative, right? Because if you did 0.85, you're going to get a positive. And actually, if you just make it negative, it's fine. But so you're going to have to figure out to the right. Let's see. This is interesting. These are the ones, this right here is where most people get confused. This is the problem right here. So my shaded area is 0.26. So remember, if it's this, it says right on here that it is the middle 26%. So this is the middle 26%. So I need to look at the values above and below that. So if this is the middle 26%, what would this be right here? Anybody have an idea?
0.5.
So the middle's 0.5. So at 0 is 0.5. So I would add 0.13 to 0.5 because it's the middle 26%. So it would be 0.66 or 0.63 right here. And then this would be 0.13 or 0.5 minus 0.13 because it's the middle. I'm going to draw this and I'm going to go back to my screen real quick here. My drawings are better anyway. So here, I'm going to draw it and then we'll come back. Okay. Okay, 0. All right. So here's my drawing. See, isn't that so much better? And this middle right here, this is 26% right here. So if that's 26%, then this right here is 13%. And this right here is 13%. Well, 13% and 13%. Are y'all with me so far? So I would do 0.5 plus 0.13 to get this right here, to get that spot. Then I would do 0.5 minus 0.13 to get this one right here. So in my inverse norm, I would use 0.63 and 0.37. This would give me my boundaries, my z-scores. Because that's the middle 26%. Does that make sense?
I lost, how come 0 is, or the center there is 0.5?
Because 50% of my area is here and 50% of my area is here.
Uh-huh.
So if I was, this is the 50% mark in the center. The center right here is
Correct.
the 50% mark. So for area.
Oh, 0.5, you mean 0.50?
Yeah.
Is what you're, okay,
Wait, if I put 50, does that make more sense?
okay. It
Because
just
it's
threw
okay,
me.
it's late, we're good.
Yeah.
All right, questions?
Okay.
So now you should have enough information to work on that homework, and we will not have class on Thursday. I will miss seeing you
Okay.
all, but but I will make sure to pop in case anybody has questions, obviously. I mean, that's what I do. I'll pop in as much as I can. I felt bad that I couldn't pop in much today, but I was stuck without electronics all day. So I will be checking in, and don't forget the the hand in homework and a quiz are due tonight. So make sure to get those done if you haven't already. And unless there's other questions, that we're still recording. Are there any more questions on the recording?
So when you say hand in, you're talking about week 5, though.
Yes,
Okay, thank you.
yes.
Oh,
All right, I'm going to turn off the recording now.